Welcome to Aptitude Destination. Please pause the video and read the question completely. How many consecutive zeros are there at the end of the integer obtained in the product 1 power 2, 2 power 4, 3 power 6 into 4 power 8 and so on until we reach 25 power 50? One common thing that you can notice here is it's increasing by 2, right? It's doubling. So basically if it's 1 under here, the power is 2. If it's 2 under here, the power is 4. 3 under here, the power is 6, which means the double of every number that we pick up here. So it's going to increase till 25 to the power 50. Now we are supposed to find the consecutive zeros that follow at the end, right? So there are only two ways that we can get zeros at the end. One is if we have 10 or any number that's ending with 0 on its own, or we get 5 into 2. Right? This is the only way we can get a 0 at the end. So even this 10 or 20 or whichever number is ending in 0, we can convert it into 5 into 2, right? Because every 10 can be converted into 5 into 2. Now we are supposed to find out how many 5s and 2s are present inside this. It's enough for us to find just the number of 5s here. Why I say that is because there are obviously a lot more 2's present in here than 5's, right? So it doesn't matter if the 2's are greater than the 5's. We need both 5's and 2's. So what I'm suggesting here is that it's just enough for us to find only the number of 5's, because the 2's are going to be greater than the number of 5's present in here. So we'll anyways have enough 2's to multiply with the 5, right? So it's basically enough for us to just calculate the number of 5's that is present in this whole expression. For that, what we are going to do is calculate the amounts of 5's. So we can say that we'll have 5, 10, 15, 20 and 25. These are the only multiples of 5 that will be present in here. And from here, we can say that this is going to be 5 power 10, right? And this is going to be 10 power 20, 15 power 30, 20 power 40, and 25 power 50. So this is the actual numbers that are present inside, which will contain 5 within them. So here we know that there are only 10 5's, right? And here we know that 10 can be divided into 5 into 2. So we have 5 power 20 and 2 power 20. We don't need the 2's. So 5, we have 25's in here. And here we know that this can be divided into 5 into 3. And we have 5 power 30 into 3 power 30, which means we have 35's here. And in here we have 2 into 10, and this 10 can be divided into 5 into 2, which means 5 is 40 times present here. And finally we have 25, which can be divided into 5 into 5. So this has 5 power 50 into 5 power 50, which means there are totally 100 5's present here. If you add all of these, we are going to get the number of 5's here, and we are going to mark that as the answer because we don't care about the number of 2's present here, since obviously the number of 2's is going to be greater than the number of 5's present in this expression. I hope it's clear for you. So if you add up all these, you will get 200. Therefore, option D is the right answer.